Extend the power rule to functions with negative exponents. So let's take a look at two examples of functions with negative exponents. And we're going to find the derivative, so that means you're going to be using the power rule here. Now, functions that are written in this particular form, meaning that functions that have a negative number in the exponent, we can just go ahead and use our basic power rule. Power rule says we take the exponent, we multiply it by the coefficient, and we subtract 1. So negative 3 times negative 7 will be positive 21x to the negative 7 minus 1. And negative 7 minus 1 will give us negative 8. And there you have our derivative, 21x to the negative 8th power. For letter B, we have negative 5 times x to the negative 2 power. We'll take that negative 2, multiply it to the negative 5 to give us 10x, and then we'll subtract 1 from the exponent, leaving us with 10x to the negative 3rd power. And there you have it, power rule with negative exponents. However, we're not always going to have negative exponents written out in this fashion. So we need to do a quick review of how we rewrite negative exponents, or how we rewrite something to have a negative exponent. So for example, if we have x to the negative nth power, hopefully remember from way back in a previous class that x to the negative nth power can be rewritten as 1 over x to the positive nth power. And vice versa, if we started out with 1 over x to the positive nth power, we could just rewrite that as plain old x to the negative nth power. And this conversion here is going to help us with our next type of derivatives. So here we're looking at 2 over x to the 4th and 7 over x to the 3rd. So before we can even take the derivative, we're going to have to rewrite these expressions to have a negative exponent. Or we're going to have to rewrite them to get the variable out of the excuse me. We're going to rewrite them to get the variable out of the denominator. And the main reason why is we don't know how to take the derivative of a quotient yet. So we're going to need to rewrite this expression to get the variable out of the denominator. And first we can pull this apart to be 2 times 1 over x to the 4th. And then we can rewrite 1 over x to the 4th to just be x to the negative 4th. And then we can go ahead and we can take the derivative of 2x to the negative 4th. We can use our traditional power rule now. We'll take the negative 4th, multiply it by the coefficient, subtract 1 from the exponent. So that's going to give us negative 8x to the negative 5th power. And we can do a similar thing with 7 over x cubed. We can first pull this apart to be 7 times 1 over x cubed. And then we can rewrite that to be 7 times x to the negative 3rd power. And then we'll take the derivative, d dx, of 7x to the negative 3rd. We can now use our power rule, take the negative 3, multiply it to the coefficient, and subtract 1, which will give us negative 21x to the negative 4th power. Alright folks, that is it. Extend the power rule of functions with negative exponents.